Okay, so we did section 7.1 and 7.2 yesterday, and that dealt with the Pythagorean theorem and the Pythagorean theorem's converse. And then we also talked about classifying angles as acute or obtuse or right. And then we practiced making sure that triangles could even form a triangle to begin with based on their side lengths, right? So we talked about all that yesterday. And today we're going to kind of go back to similar triangles, but we're going to apply them to right triangles. So today's lesson is about similar right triangles. And we're basically going to work off of this same theorem through this whole lesson today. And we talked about, it has the word altitude in it. And we briefly mentioned an altitude. I think we first were introduced to it in chapter 5. And an altitude is if we drop a perpendicular line from one angle to the other side of the triangle, then that's an altitude. So perpendicular lines form what kind of angles? Right, 90-degree angles. Okay, so if we drop an altitude from one vertex of a triangle to the other side, then we make perpendicular lines. Therefore, we make right angles. And then we divided the triangle into smaller right triangles. Okay? So theorem 7.5 from the textbook says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Well, we spent a lot of time in chapter 6 talking about similar triangles. What do similar triangles have? Two things. Congruent angles and proportional sides. Very good. Okay? Congruent angles and proportional sides. So we're going to be working with proportions today to find side lengths. Okay? Before we do that, let's just talk about how this triangle got broken up. So angle C was the original right angle. They dropped an altitude to the hypotenuse right here. I guess that should have a coordinate over here. A B. Probably got erased. This should be a B, so add that to your picture if you have the picture in your notes. I still have y'all frozen, no wonder. There it is. So, we had originally had a right triangle, but now we have two more right triangles, because this is a right angle over here as well. So we have a total of 3 right triangles now after we drop that altitude. All right. It says identify the similar triangles. So we got 3 triangles, and they're all similar to each other because my original right angle was at angle T. This is an altitude to U, so that makes a perpendicular line with that hypotenuse. So now we have 3 right triangles. So it says identify the similar triangles, then sketch them to have the same orientation. So we're going to draw these 3 right triangles with the right angle in the same spot. So we're going to have to take some and rotate them. So what I'm going to do is take the original triangle, RST, and draw it like it is already drawn. I want to do a red pen. So label your points. RTS, the right angle is at T. So there's my first right triangle. So next I want to draw these 2 little triangles to where they're oriented the same direction. That means the right angle will be in the same spot. Does that make sense? So let's look at this one first. Can y'all look at this bottom little one for me? I've highlighted it yellow on my screen. So what is my right angle for that triangle? It's where? At U. So my right angle needs to be U. So that means I'm kind of like flipping that around this way. Does that make sense? So if I do that, what vertex goes right here at the bottom left? T. And so that means the top one will be what? S is not in that triangle. All right. Okay, do y'all see that? It's like I take this triangle and I rotate it around and put the right angle right here. Also, it might help you to look at short legs and long legs. Like UT appears to be shorter than RU. Does that make sense? In the same way in the big triangle, you can't really tell that way though. That's just because my drawings are always off. But yeah, if you just take it and rotate it, that's how it goes there. So the white triangle at the top is my other right triangle. And where is its right angle at? It's at U also. So if I rotate that one again, all the way around to this orientation, what's in my bottom left corner? And the top one is T. So if it says identify the similar triangles, then when you write their names, you write them with the corresponding angles. So R corresponds to T corresponds to S, and then P corresponds to angle U and to angle U, and then the top angles F corresponds to R and also to T. Symbol. Y'all see how we rotated those around? All right. So we are going to use similar triangles to help us find a missing value. I'm going to give you a second and let you copy that picture. If you can't read something, let me know. And I am not going to lie. Sometimes these things can get confusing because there's a lot of information in these pictures. We've got 2 legs and a hypotenuse times 3 triangles in one picture. So how many different right triangles do we have? 3. Okay. So you want to go with one where you have a lot of information on. So don't I know all 3 side lengths for the largest triangle? Yes, I know the short leg is 3, the longer leg is 4, and the hypotenuse is 5. Okay. So that might be the triangle I want to base everything off of to help me find X. Now X is a leg for the bottom triangle, and it's also a leg for the top little triangle. Do y'all see that? Y'all see that? Well, I'm going to use the bottom triangle with my big triangle. So I'm going to highlight it and color it so I know which one I'm looking at. So if you just want to like shade the inside of it or put a little smiley face inside that one on your notes to let you know what you're talking about. So I'm comparing 2 things. I'm comparing my big triangle to my little triangle. And I'm using X is the short leg of that triangle, is it not? The short leg. And what other information do I have for my yellow triangle? The 4, which is the what of that triangle? It's the hypotenuse because it's across from the 90-degree angle. Do y'all see that? So I need to use short leg and hypotenuse because I know the hypotenuse for both triangles. And I need to find X, and that's in that short leg. Does that make sense? So you use what you're trying to find. Okay, so I'm going to fill in a proportion, and I've just labeled everything. So when I do my proportion, everything in my first fraction is coming from my big triangle. Everything in my second fraction will be coming from that small yellow triangle. Okay? So in the big triangle, what's the length of the shortest leg? 3. Over, what's the length of my hypotenuse in the big triangle? the hypotenuse in the big triangle? 5. Okay, so everything in my first fraction came from the big triangle. Now I'm going to use my little triangle. What is the length of the short leg? That's what I'm trying to find. Over what is my hypotenuse? 4. Okay. So that's how you set it up. You're comparing two triangles, and then you use two legs or a hypotenuse of what you know, the information of one of them, and you got to have your missing piece somewhere. Okay? So we solve a proportion by cross multiplying. I'm going to have 5x equals 12. And then divide by 5. So x equals 12 over 5, or you can say 2 2/5. And let's see if that answer makes sense. That's this leg. The hypotenuse is 4, so it's better be smaller than 4. Is it smaller than 4? Yes. Also, in this top triangle, it's also a leg with a hypotenuse of 3. So is it smaller than 3 also? Yes. So a leg can never be larger than the hypotenuse. That makes sense. All right, we're just going to practice these. I know they're confusing. Okay, that's why I try to label everything when we set it up. And you could use totally different proportions just depending on how you see it. All right? So here's another triangle. I'm going to let you copy it down for a second. Now this one's similar to the last one in that I know all the lengths of the biggest triangle. Okay? So I'm going to use my big triangle. And do y'all want to use the little triangle on the bottom or the little triangle on the top? Somebody tell me. You want to use the top one? Okay. I'm labeling that the little triangle. And what am I trying to find? X, right? Is X a leg or a hypotenuse of that little triangle? It's a leg. All right. It's kind of hard to tell, but I think it's probably the short leg, but I'm not 100% sure. And what else did they give me in that triangle? The hypotenuse. Are y'all with me? So I need to use a leg and a hypotenuse. Because that's what I'm trying to find a leg, and I know the hypotenuse. And I believe it's going to be the short leg. I don't know. Let's look at the orientation of that. M is my right angle here. I rotate it around. No, it looks like my long leg. It looks like it's good. L is going to line up with J. Y'all agree? Y'all agree? Okay. So the 5, that's the hypotenuse. Oh, it's going to be the short one. It's going to be 5. Y'all see that? This triangle, to make it oriented the same way, I'm going to rotate it around. So it's going to match up with the 5. It's just not going to be as big. Does that make sense? So I'm looking for the short leg. Does that make sense? If I put this right angle where this right angle is, rotate the whole the little triangle to where it's oriented with the big triangle. All right. So, okay, in the big triangle, what's the length of the shortest leg? 5. Over, what's the length of the hypotenuse in the big triangle? 13. Equals, what's the length of the short leg in the yellow triangle? X. Over, what's the length of the hypotenuse? It's 5. It's 5. Y'all with me? All right. Cross multiply. I'm getting 13x equals 25 divided by 13. And you can leave it 25 over 13. Or you can say it is 1 and 12/13. That makes sense? So sometimes you got to do some flipping around in your head to say, oh, if I move these angles around, this angle is going to match to that angle, so that corresponds with the 5. It gets confusing. That's why I try to label everything around my proportion. Because everything here is in my big triangle, everything here is in my little triangle. It takes practice. All right, y'all try the next one. That's interesting. Why that question mark's there? I know it, I can go to blank. Right. Okay, so there's not as much information given here. Correct? Correct? Okay. So obviously I'm trying to find y. And y is a leg of the big triangle, correct? It is also the hypotenuse of the top triangle. Y'all agree with that? Y'all agree with that? So, okay. So, do I know the hypotenuse of the largest triangle? What is it? It's 9. Because 3 plus 6 is 9. Right? So let's do that. Let's do the big triangle and the top little triangle. So I'm going to do big and then the small triangle. And I'm comparing the leg to the hypotenuse. So for the big triangle, the leg we're trying to find is y, correct? And that's over the hypotenuse of what? 9. Equals. Let's say, use that top little triangle. The leg that they gave me was 3, correct? Over y. Ha. So y'all might be thinking, how in the world can I do this? Right? Well, we know how to simplify radicals, don't we? Yeah. What's y times y? Y squared equals 9 times 3 is, and then we take the square root. So that's y equals radical 9 times 3, which is 3 radical 3. Questions? This is confusing, isn't it? Is anybody confused? It's confused. Guess how you get good at it? You practice it. So we're going to do that in a second. First, I want y'all to try this one, though. Doesn't have as much information, but it has enough information. we'll work it as well. And yes, I got a radical in my answer. So if y'all got a radical in your answer, you're probably not wrong. I can check them with each other. All right, could we get any information at all from this bottom triangle right here? No. So obviously I'm going to use the big, huge triangle and then the top little one right here, right? There was not enough information other than we know this length is 8, right? How do I know this length is 8?
That's 2 plus 8 equals 10.
That's right, because that together they make 10 to make that hypotenuse. So I'm going to use the big triangle and the small triangle on top. And what parts am I working with the big triangle? The leg and the hypotenuse that I know both the measures of, right? So what's the leg length in the big triangle that I need to know? Okay, over what's the hypotenuse of the big triangle? 10. And on the little triangle, which is the one on top, what's the small leg? 2. And what's the hypotenuse of that one? Okay. So any question about how I set mine up? You could have these reversed, the small one in front of the big one. It doesn't matter. As long as you have this ratio for your big triangle and this ratio for your little one, okay? So cross multiply. What's K times K? Equals what's 10 times 2? And then you take the square root of both sides. How do you take the square root of 20 when it's not a perfect square? Radical 4 times 5, which equals what? Raise your hand if you got 2 radical 5. So y'all are doing better than you thought. All right. So that is actually the end of notes. And next comes practice. But I want to work one of your practice problems with you. Is that okay? So this worksheet is your homework and your classwork. And I'm going to work number 1 with you guys because it's a little bit different than any of our examples. And while I'm passing out your handout, I'll tell you the rest later. Let's work number 1 first. I don't want what I'm going to tell you to be on the recording. Because I might change my mind the next time I teach this lesson. All right, so on your handout, look with me at number 1. Draw the picture. No making fun of my drawing. I know it's terrible. So right angle here, x 36, 60, and this one's 48. Okay, we're looking for x. Oh, I found that. Yikes. Okay.
We know that sense.
Yes. Okay, so here's what I said. I said x is part of that big hypotenuse, right? But I don't know that hypotenuse. And I don't know either other leg of that triangle. Y'all see that? So I need to find me another leg of that big triangle so that I have something to work with. Make sense? Or do I even have to do that? Who says I have to use a hypotenuse? Because I've got leg and leg for this triangle and leg for this triangle, correct? Y'all see that? Well, let's do that. I made it too hard. So, let's compare left triangle and right triangle. And we're going to do short leg over long leg. So you just got to take whatever information you have and roll with it. I didn't have any hypotenuses. If I wanted to use this hypotenuse, I would have needed to find another hypotenuse, which would have been this one, and use a squared plus b squared equals c squared, which is what I did when I worked it out the other day. And actually, I don't need it because if I have short leg and long leg, I don't have to do anything else because I have the same parts of similar triangles. So in the triangle on the left, which one appears to be the shortest leg, X or 48? Your picture is better than mine, so look at your picture on the worksheet. 48 looks like the short leg, and the long leg looks like X. Y'all agree? Hang on just a second. We have a visitor. All right. So y'all okay? X is my short leg of the left triangle. 48 is, no, I said that backwards. 48 is my short leg. X is my long leg. Y'all see that? Your worksheet is a better picture than mine. It's more drawn to scale. Y'all see that? All right, from the right-hand triangle, which side? Oh, obviously, if you have both measures, you know which one's the short one, which one's the long one, right?
Yeah.
What's the short leg on the right-hand triangle? 36. Over what's the long leg? 48. So then we're going to solve this proportion. So cross multiply. X times 36 is 36x, guys. And what's 48 times 48? Say it again, 2,304. And then if I divide both sides by 36, what do I get? 64. And I'm just going to go ahead and tell you, every answer on your worksheet will be a whole number integer. Be a whole number. So you shouldn't get any radicals or any decimals for answers. So I'm going to stop the recording. Goodbye.